I have these set up so that you are only allowed to view, but if you make a copy, you'll be able to edit the document and add in your own notes, which I highly recommend. It will help you out much later on. After you have made a copy of the notes, then you'll need to make sure that you have downloaded or opened up the R script for independent samples and also the ANES 2018 dataset. Both of these have been sent to you in an email, and they are also on Classroom if you're able to download it from there. But where we're going to start out today is with the notes document. The first thing you're going to see when you open it up is that we're going to start off by just talking about what is an independent samples t-test. You use an independent samples t-test to determine whether or not there is a relationship between two variables, and specifically when your dependent variable is continuous, meaning that it is an interval or ratio measure, it runs the number line. And your second variable, your independent, is in categories, and specifically only two categories. If you have more than two categories, then you would use an ANOVA analysis. But when you only have two categories, the appropriate test is an independent samples t-test. The way this test works is it looks to see if the averages, so as noted here as mu, this funny little u, if the average is different between category 1 and category 2 based off of your dependent variable. If there's a big enough difference, then you're going to achieve statistical significance. If there's not a big enough difference, then we would assume that they're essentially not significant and there's no difference between the two groups. The way that we set up these hypotheses is we use this notation down here. So the null hypothesis is that the overall average is basically the same as in group 1, as in the same as basically group 2. The alternative is that at least one of these groups is unequal to the other one, and that's noted with this equals with the slash through it. So we're getting into more sophisticated analyses, so that means we have to start talking about assumptions. In an independent samples t-test, there are some important assumptions. The first one is that you use random samples when creating your information. So we're just going to assume in the ANES dataset that they use good random sampling practices when they were asking people if they would complete the survey. We have no control over this first one, I should be clear. The second one is that your dependent variable is measured as a true interval or ratio level of measurement, meaning it runs the number line. It's a continuous measure, something like a percent or a count or a rating. Sometimes people use an independent samples t-test when they have a Likert scale, especially if that Likert scale is between like 1 to 7 or 1 to 11. They assume that's a big enough difference in values that it's okay. I am someone who is going to say no. I don't like that. I feel like you should use a different method of analysis. But I do want to let you know that there are some people out there who say that that is variation enough and it's okay. The third assumption is that if the number of observations is less than 50 in each group, you don't have to assume that there's a normal distribution. But if your observations in each group are larger than 50, you need to you want to assume that they're normally distributed. So you will be looking at these groups to see, are they roughly equal to each other in terms of their distribution. If you get a group that's very different from the other one, it can sometimes be an indication of it may not be that they're statistically significant, but actually there's just a group of people within one of the groups that's just really, really different. And so really what you're finding out is something unique to that group and not something that's a reflection of the broader population. To do an independent samples t-test, it's pretty straightforward. The first things we're going to do is just look at the dependent and independent variable. We're going to describe them, find out what the typical case is. We're going to come up with a research question of why these two things might be related to each other. Then we'll set up our formal hypotheses. We'll run the test in R and interpret the results. So first things first, I want to switch over to RStudio and show you guys how to open up the data. Again, I'm assuming that you have already downloaded this data either from an email or from Classroom. When you open up the script, that's the first thing you're going to want to open is this independent samples t-test R script. You'll do that by going up to File, New File, and you're going to open up an R script. Or you can go to Open File and search on your computer for it. I have already run line 9 to install these packages. Sometimes when you install them it takes a few minutes, so just to save video time, I went ahead and already installed them. Next I'm going to run lines 10, 11, and 12. This will open up these downloaded packages so that I can actually use them in my session. The next thing we're going to do is step 2. We need to open up our data set. You've got a couple of ways that you can do it. You can delete this hashtag, and that turns this line of script on, and then search on your computer for the ANES dataset, or you can import it by coming up here to Import Dataset. I'm going to use the Import Dataset method this time, but if this ever gives you trouble, use this line, the read in an SPSS file from the script. So I'm going to come up here to Import Dataset from SPSS. The ANES is not saved for you as an Excel data sheet, but actually an good old-fashioned SPSS. Here it is. I went right past it. It'll take a second for it to load, but we get the preview of the data, and then we're going to click Import. So this opens up, again, a preview of the data, but now we have the data set open. There's 2,500 observations, 86 variables. So now that we have the data open, let's start by just looking at our variables. So first, I'm going to go back to my notes, and I'm going to see, okay, what are we going to talk about? I personally thought it would be interesting to see how people felt about Supreme Court Justice Brett Kavanaugh and whether or not there were difference of feelings towards Brett Kavanaugh based off of respondents' gender. So if you know nothing about the Supreme Court, that is okay. You can Google Brett Kavanaugh to read more about him and read more about the contentious nature in which he was nominated and ultimately voted to sit on the Supreme Court for a lifetime appointment. The short story is his nomination process was very tense. There were credible accusations of sexual assault levied against him, although the accusations went as far back in time as to when he was in high school. While there were no formal charges ever against him, there was some pretty gripping testimony on behalf of a woman who claimed she was assaulted by Justice Kavanaugh when she was in high school, Dr. Christine Blasey Ford. That was broadcast on television and all that was talked about for many days in the news cycle. So I thought it would be interesting to look, because this survey was going on not long after that, to see how much of this people picked up on and whether or not there were differences in how people perceived Kavanaugh, whether they liked him or didn't like him, and if there were differences based off of gender. So looking at some hot topics. Never going to shy away from the hot topics, and it's especially fun to use statistics to see if there are meaningful differences here. So the first thing we're going to do is set up our research hypothesis, and the way that we're going to do this, we're just going to fill in the blanks, and I'm going to say we're going to start with the unit of analysis. Since this is survey data, the unit of analysis are people, but I'm going to call them respondents. Respondents are more likely to have respondents who identify as male are more likely to have, we'll say, warmer feelings towards Justice Brett Kavanaugh than respondents who identify as female. Now it would be totally fine to switch this up and make it respondents who identify as female are more likely to have colder feelings towards Brett Kavanaugh than respondents who identify as male. It's totally fine. The first thing we're going to do after we set up our hypothesis here is, well, I guess I should say this is not our hypothesis, our research question. Before we move on to actually doing analysis to see if there is a difference, we're just going to look at these variables one at a time. So the first thing we're going to do is use R to find these descriptive statistics. So I'm going to go back to R, And line 20, the summary ANES 2018 small for feeling thermometer of Kavanaugh. Let's run that, and we get our results down here. So there's a minimum of 0, a maximum of 100. There were 114 people who didn't answer the question. But let's come down here. We can do a minimum of 0 and a maximum of 100, which is the full extent of the thermometer. So your thermometer can either, you can go as low as 100, as low as 0, and as high as 100. The mean is 44.07. And the median is 41. So pretty close together. And then we're going to fill in here, what do these descriptive statistics tell us about respondents' average feelings towards Justice Kavanaugh? Well, the mean is 44 degrees. This is actually pretty chilly. The overall picture is that some people really loved him. Those are the 100s. And some people really dislike him. Those are the people who rate him as a 0. So the next thing we need to look at is males and females. So how many males, how many females do we have? Oh, wait. Sorry, I'm getting ahead of myself. I want to show you what this looks like as a histogram. So 23 and 24, just make a basic histogram using ggplot to give you a sense of the distribution. So one of the things that I didn't pull up here was the standard deviation. I'm sorry, but you can see the sort of swings here when you look at it as a histogram. So here's our average is over here in the 40s, right here. But when you look at this, there's a pretty strong group over here, and then a pretty big group over here. Like this is actually a pretty nice U distribution, or maybe a slight like bird wing or W action happening here. What this tells you is that 1, this is not a normal distribution, and 2, people have some pretty strong views, both positive and negative, towards Justice Kavanaugh. The next thing we want to do before we see whether or not gender and views on Kavanaugh are related, we're going to look at the breakdown of males and females in this survey. First thing we have to do, I want to show you this. The STR stands for structure. And we're going to look at the structure of this variable, and you can see it's a DBL plus a label. Double essentially means that it's a number plus a decimal place, and it's totally fine. It's totally fine, even though all the actual data is either a 1 or a 2. What we need to do is actually change the structure of the variable to be read as a character, because we need this to be categorical to work for our analysis. So it's pretty easy. You just want to run line 29. That creates a new variable called gender2. And gender2 will read this not as a number with a decimal place, but as either you're a group 1 or you're group 2. You're identified as either male or female. Line 30 will show these groups in a small table. So there are just over 1,100 ones and almost 1,400 twos. Let's see. If you want to know the 1s and 2s, you would need to look in the code book. But I'll just go ahead and tell you that 1s are males and 2s are females. So we're going to take this information and record it in our notes. So there were, I'll go away, 1,101 males and 1,399, is that right? Yeah, 1,399. Females, and then total number is 2,500. So a little bit leans more balanced towards females, but overall pretty well balanced actually, males and females. Now we're ready to set up the hypothesis. So I'm going to show you guys a little trick here. I'm actually going to come back up here to the beginning of the notes, and I'm going to copy this, and I'm going to bring it down here, because like, why retype it when it's already created for you somewhere? And we'll just move this here. But what we're going to do is we're going to change out these values. So the overall feeling towards Justice Kavanaugh was 44. And then we're going to look up to see what is the feeling, the average for males and females. But what you need to know here is that we're going to be comparing the overall feeling to the feelings for males and the feelings towards Kavanaugh by females. We're going to see if there's a difference. So the null hypothesis is that there is no difference. That essentially males and females both feel roughly the same towards Justice Kavanaugh. The alternative hypothesis is that there is a difference. At least one of these groups is different from the overall or is different from the other group. So in order to get those numbers, we're going to go back to R and, oh, sorry. I'll show you a quick bar plot of the two groups so you can see, yeah, they're roughly equal. There's slightly more females than males, but pretty close. Step 5, I know this looks like a lot, but what this is doing is it's going to give us the average and the standard deviation feeling towards Kavanaugh based off of gender. So you would highlight line 38 through 43 and click Run, and then it gives us this nifty little table down here. So average feelings for males is 49.8. So I'll put that down here as well. And then average feelings for females is 38. Oh, that's the standard deviation. My bad, sorry. 39.4. Was reading the wrong column. It's easy to do. So what this t-test will do is it's going to see whether or not these differences are statistically significant. And you can see already that like males are already a little bit warmer towards Kavanaugh compared to the overall, and females are colder towards Kavanaugh compared to the overall average of 44. None of these are particularly an indication of this person being well liked. Like, we would assume feelings of warmth would be at least over 50 degrees, but in the 60s, 70s, 80s, those are indications that you are well liked. People have strong, warm feelings about you. So to run the test, we have to actually look at the assumptions. We've got to check whether or not we've got normal distributions, because we have groups bigger than 50, and we want to see if the variation within those groups is roughly equal. To do that, I've already, all the code is written for you. I'm just going to scroll this up. So we're going to start here at step 6. We're going to run what's called the Shapiro-Wilk normality test, and we have to do that for each group. So the first one, I'm going to run this test, Shapiro test, for group 1, which is males. And we get this value down here. It means that there are 16 zeros in front of that 2. In other words, this is a statistically significant result. Here's the thing that's tricky. When you are testing assumptions, if you get a statistically significant result for an assumption, it means that you violate that assumption, which is bad. So even though we've got more than 50, this is not a normal distribution. But let's look at gender for women. Same thing. So both groups are not normal. So there's not much we can do about it. It's just something we would need to acknowledge, that we are in violation of that assumption. The next assumption we need to test is equal variances. We want to know, okay, so our groups might not have a normal distribution, but within the group, is the variability in the data roughly the same? We assume the goal is that it is roughly the same, but let's test it and find out. Let's see, we get an f-test of 1.16. P-value. Oh, brother. What we're looking for here is a number that would be bigger than 0.05. That would be an indication that it's not statistically significant, so that we would have support for our null hypothesis that the variances are equal. Because we have a statistically significant result, it means that we violate that assumption as well. Not the end of the world. What we do when we actually run the t-test is that we set the variance dot equal to false. So when you are doing this, if you are using different data, for example, doing this for a homework, when you run this assumption, if you get statistical significance, so a number here for p that is 0.05 or smaller, you need to set this part to false. If this is not statistically significant, you would set this to true. So let's run the test, see what happens. All right, so they give us the means again for the two groups. We get a t-score, degrees of freedom, and a p-value. So let's go ahead and record this information in our results. First, we need to put in the average and standard deviations, which we actually already pulled. If I scroll up a little bit, we've got that information right here. So that's what we're going to put in first in our table. We've got 49.8, standard deviation of 38.5, and 1101 for number of observations. For females, it's 39.4. Standard deviation of 35.6. And number of observations of 1399. I feel like that's right. Yeah, we're good. Okay, and then we'll come down here to our t-test, and we get a t-score of 6.82. That goes right here, 6.82. Let's find our degrees of freedom. That is 2210.9. And then the significance. So the significance, what this means is that there are 11 zeros in front of this one. So what we're going to do is just put it in here as 0.000. When you have to do this for homework, I highly recommend you just copy these tables, paste them into your homework, and update the titles and the categories as needed. Save yourself some time making tables. So now we're going to get into what does this all mean. So what are the results of the analysis? So we can see the difference is in feeling towards Kavanaugh is about, let's see, about 10 degrees really between males and females. Males feel cold, but warmer than the overall average of 44 degrees. In fact, I'm going to go back and add that number because that just makes this more accurate. Feel cold, 49.8 degrees. Females feel whoa, spelling is hard. Typing is hard too. And then the next question, is there a statistically significant association between gender and feelings towards Justice Brett Kavanaugh? We would determine that by looking here at the significance. Because this number is less than 0.05, it is statistically significant. So we're going to say yes. The p-value obtained is less than 0.05 at 0.000, which means there is less than the time that we would check. The null hypothesis and that be the wrong decision. So, do respondents who are male or female have warmer feelings towards Kavanaugh? Yes, these results indicate there is a real difference in average feelings towards Justice Kavanaugh. Men tend to feel warmer towards him than females. So last thing I want to show you before we stop is back in R, I have the script already created to show you this as a box plot. So let's run 66 through 71 and let's look at the difference between these two groups. It's very helpful in my opinion to see these things visualized. And what this shows you is that males sort of run the gamut. There are some males down here at the bottom of the box that really don't like Justice Kavanaugh. Their ratings for him are closer to the 0. But there are some men up here over, I don't know, maybe that's the 80, 90 mark, that feel pretty warmly towards the justice. But on average, they're hovering right here at 50 degrees of warmth. Females, on the other hand, their whole box is positioned lower than the grouping for male. This down here, this is the 25th percentile. The top of the box represents the 75th percentile, and you can see the average right here, this solid line, is lower than the average for men. So what this shows you is that overall, women tend to like Justice Kavanaugh less. They viewed him more coldly, and that this is a statistically significant result, which we know that from our t-test, despite the fact that we had 2 violations in our assumptions. For now, that's all you need to know. You don't need to worry about how you would correct for those assumptions other than setting the variance.equal equal to false if you end up getting a statistically significant result for your equal variance test. That's where we're going to stop today. Best of luck to you, and I'll be back again here with you soon.